Right, so we've got a solar cell and we're just going to get the fan going. So that's the sun from the solar cell driving a little motor driving a fan. Now what we're going to do is I'm going to break the plug. Now what we're going to do is plug in the red side to a hydrogen fuel cell. I'm going to plug the black side into the opposite side of the hydrogen fuel cell, and what we should find is that if we look carefully at the hydrogen, it will gradually start to go down as hydrogen is being produced by the fuel cell, and I can see that going, and then I can also start to see the oxygen going as well. The oxygen, of course, H2O, the oxygen's being produced at half the rate of the hydrogen, so we're now approaching 8 to 10 centimetre cubed of hydrogen being produced, and I can see about 4 or 5 of oxygen being produced. We need a nice sunny day, the sun's shining, electricity falls on the solar panel, goes into the solar cell, this fuel cell, and this fuel cell is splitting up water into hydrogen and oxygen. Right, okay, so we've now got up to maximum amount of hydrogen, so I'm now going to disconnect the fuel cell from the photovoltaic cell, and now I'm going to connect a fan directly to the fuel cell, and this should automatically reverse the fuel cells, and there we have hydrogen powering a fuel cell and powering an electric motor. So we've turned light into chemical energy, and the chemical energy is now being turned into electricity. And we can see it really runs for quite a long time. This does get a little bit slower, and this is because the amount of hydrogen and oxygen, as they go down, the pressure is slightly less pushing it through, and so not as much hydrogen and oxygen get through, and therefore this system slows down slightly. But at the moment it's doing a fair whack, and we've used up now about 8 or 9 centimetre cubed of hydrogen to power this.